We are going to be solving this with a very brilliant method. First of all, let us rewrite x root as 1 over x, then minus 60 to the power of 1 all over x, then that equals 40 all to the power of 1 over x. Now, if you notice something, you notice that they all have 10 in common. So we can rewrite as 9 times 10 all to the power of 1 all over x, then minus 6 times 10 all to the power of 1 all over x. And we can also do the same for 40, then to the power of 1 over x. Now, what we're going to do here is that we are going to be bringing out the coefficient of 10 out of the power. Let me draw this here. Then we have 10 to the power of 1 over x, then times 9 to the power of 1 over x. So we have minus 10 to the power of 1 over x, then times 6 to the power of 1 all over x, and this equals 10 to the power of 1 all over x multiplied by 4 to the power of 1 all over x. From here, we can easily factor out 10 to the power of 1 over x since it is common to both sides. Then we have minus 6 to the power of 1 all over x. We can also bring this to the other side, and then we have minus 10 to the power of 1 over x, 4 to the power of 1 over x, and this equals 0. So finally, if we try to factor out 10 to the power of 1 over x, we have this 1 over x, then minus 4 to the power of 1 over x to be equal to 0. And now, if you look at this, 10 to the power of 1 over x equals to 0 is not valid. Why? Because 10 to the power of no real number can give us 0. 9 to the power of 1 over x, then minus 6 to the power of 1 over x, then minus 4 to the power of 1 over x to be equals 0. Now here we're going to be doing something very brilliant. We'll be dividing through by 4 to the power of 1 over x. If you can guess why, that's very good. But this is going to make our expression or equation easier to evaluate. Now, after doing this, since they have the exact same power, we can use the law of indices to group them together. So we have 9 all over 4 all to the power of 1 all over x. That's a common power. Then we have 6 all over 4 all to the power of 1 over x. And then minus, this here cancels this to give us 1. So minus 1, and that equals what? 0. Now 9 divided by 4 can be written as 3 all over 2 all squared, because 3 squared is 9 and also 2 squared is 4. So we can categorically write it as 6 divided by 4 gives us 3 all over 2 all to the power of 1 over x minus 1 equals 0. Guys, we are not done here. We know so well that we can swap the position of these powers. 3 all over all to the power of 1 over x, then all squared, minus 3 over 2 all to the power of 1 over x minus 1 equals 0. Now here we can make use of a very brilliant substitution, because this leg or base are the same. So we can just say let 3 over 2 all to the power of 1 over x equals y. But we must set our condition where y is greater than 0 because of the logarithm function, and also y must not equals 1. Y must not equals 1, because if y equals 1, it's going to mean that we're going to have a 0 power. If we have a 0 power, it means x will be equal 0, which will be invalid and not accepted. So we go further to rewrite this, and we have y squared minus y minus 1 equals 0. And then moving further, when we solve this quadratic equation, we'll find out that y1 equals 1 plus square root of 5 all divided by 2, and also y2 equals 1 minus square root of 5 all divided by 2. And if you take a close look at this, we'll see that this value represents the golden ratio phi, and also this represents negative inverse of phi, which is the golden ratio. And don't forget from our domain that y must be greater than 0, but here now we have negative phi, so it means that this solution is invalid. So therefore the only solution that we can have is y equals 1 plus square root of 5 over 2, which is phi. So let's substitute back our value. Then we'll say 3 over 2 all to the power of 1 over x equals the golden ratio, which is phi. And now when we take logarithm of both sides, we'll find out that 1 over x log 3 over 2 equals log of phi. Then when we divide both sides by this, find out that 1 over x equals log of phi divided by log 3 all over 2. And then when we take the reciprocal of both sides, we'll find out therefore that x should be equals log 3 over 2 divided by log of phi. And then when we input this into our calculator, putting the value of phi in mind, we'll find out that x will be approximately equals 0.84259 as our correct and the only valid solution. If this solution makes sense, don't forget to subscribe and let me have your thoughts in the comments. Have a good day.